purpose of the project. It's well known that the optimal angle for the projectile motion from the ground for max distance achieved is 45 degrees. So we wanted to find and determine if the varying initial height would have an impact on what the optimal angle should be and what those angles would be for max distance. So we decided to use a nerf gun and use the kinematic equations to determine how the height will affect the optimal angle and distance traveled. The assumptions for our calculations included the kinematic equations shown below, having negligible drag force and 0 wind speed. And the assumptions for our experiment included the movement along the X and Y plane, and if the nerf gun fires consistently.
Try and go to that.
Alright, what is that, 60?
Yeah, 60.
Yeah, you're ready to go. So during the experiment, we had a tape set up measuring the height of each shot, and attached to the nerf gun, we had a protractor with a string hanging down to assume and show what angle each fire is shot at. And the one on the left shows 45 degrees, and the right shows 30 degrees.
Throughout the experiment, we collected data. We measured the height, angle, and distance of each shot, and then using the kinematic equations, we derived an equation to determine what the velocity of each of the shots was. Once we had collected all the velocities, we then put them all into Excel and made this graph. We found that the Nerf dart had an average velocity of 43.59 feet per second, and that this had a standard deviation of 1.43. Here's a list of our derived equations. The first one was for the optimal angle needed for the maximum distance. The second one is the max distance that would be found, and the third one was what we used to determine what the velocity of each of our experimental data points was. Here's the Matlab code that we wrote. It will give the optimal angle and maximum distance that the Nerf dart can be fired at for each height. It will also plot that projection.
So this is an example problem that we solved using our previously shown Matlab code. So what we have right here is a depiction on the graph of the height and the distance traveled for our optimal angle, which was 42.75 degrees, and a max distance of 63.81 feet.
In conclusion, we found that height did have an impact on the angle needed for optimal distance to be traveled. There were a couple possible errors that might have occurred during this experiment. This included that the angles may have been slightly above or below 30 and 45 degrees. The initial heights may have varied slightly. The exact location of where each dart landed may have been spotted wrong, and the Nerf gun may not have fired consistently. The hardest challenge was to set up our experiment and accurately record the data. Luckily, using the Matlab code, we can determine the optimal angle with any varying height.